Dear students, in this lecture, we are going to see the different methods of measurement of voltage standing wave ratio. This is the basic definition of standing wave ratio, right? If we know the values of voltage maximum and voltage minimum, then the expression for voltage standing wave ratio is given by the ratio of Vmax by Vminimum. Right? So if I want to measure the voltage standing wave ratio, VSWR, we should find the values of Vmax and Vminimum present in a transmission line. After knowing this, we can calculate this VSWR ratio by using this formula Vmax by Vminimum. We are going to look into three different methods of measurement of VSWR. The one is open wire line method, coaxial cable, directional coupler. This is the open wire transmission line. As you can see here, there is a voltage source from which the signal is being transmitted, and we have a slotted probe. And this probe can be easily moved, and freely it can be moved from one end of the transmission line to the other end of the transmission line. So this is a movable probe. Now, as we move the probe along the length of the transmission line, we can measure the voltages at different points on the transmission line with the help of this voltmeter. So as it moves, by noting down the different values of voltages on different points of the transmission line, we can come to the conclusion of the value of Vmax as well as Vminimum. By tabulating the different values of voltages along the length of the transmission line, we can finally ensure which is the maximum voltage and which is the minimum voltage. Once this value is known to us, then by making use of the formula VSWR is equal to Vmax by Vminimum, we can directly find the value of VSWR. This method is called open wire line method of measurement of VSWR. The second method is called coaxial cable. As we look into this, we have a signal generator. This is the source which generates the signal, and this signal is given directly to the coaxial cable. This probe slotted line is nothing but the coaxial cable. Now, in between the signal generator and the coaxial cable, we have to ensure that the signal is transmitted only in one direction, which means from the source to the cable, the signal should pass through, and there should not be any reflected signal back from the probe towards the source. In order to ensure this, we are placing a pad, and this pad is a resistive element. This is a resistive element, and the function of this resistive element is if there are any reflected power from the probe towards the signal source, then this reflected power will be completely absorbed by this resistive element, which is a pad. This is the purpose of this pad, and it is inserted and placed between the signal source and the coaxial cable to absorb all the reflected power from the coaxial cable. Now, this is there will be a slot in the coaxial cable, which is under test. And through the slot, we can freely move a probe. A probe is inserted, and this probe can be moved freely through the slot, entire slot. The other end of the probe will be connected to a detector, which is again connected to a voltmeter. And this slotted line, coaxial line, is described here in this picture again. There is a slot present in the coaxial cable. Through the slot, we can freely move a probe. This probe is connected to the voltmeter. So whenever we move the probe from one end of the slot to the other end, we can note down the voltage values, or we can measure the voltage values at different points on the slot with the help of this voltmeter. By noting down the different values of voltages throughout the slot, we can find which is the Vmax value and which is the Vminimum value. Once we find this Vmax and Vminimum, then we can easily determine the voltage standing wave ratio by using the formula Vmax by Vminimum. This is how VSWR is measured using this coaxial cable. The next method is called directional coupler method of measurement of VSWR. And this directional coupler method, in this method, we can directly measure the SWR. So here again, we have a coaxial cable, and in this coaxial cable, we have made two holes. Let us take this as X and this as Y. There are two holes, and the distance of separation between these two holes is lambda by 4. Now, to these two holes, we are connecting a directional coupler. This is a directional coupler. We have connected this directional coupler across the two holes that we have made, which is separated by lambda by 4 in a coaxial cable. Now, through this hole, a part of energy will be coupled into this directional coupler. The energy that is passing through this coaxial cable from the source to the load, this energy, a part of this energy will be coupled into the directional coupler through this hole X and Y. And it will be moving in either direction. It will be moving towards right as well as towards left. Now the part of energy which is moving towards right, we are naming it as incident voltage VI. So VI is the incident voltage, and this is moving towards right. Next, similarly, a part of energy will be moving towards this direction also, that is towards left. We are representing it as reflected voltage. And this reflected voltage is the voltage which is moving towards left. So this is VI and this is VR. Once this VI and VR are known to us, this VI and VR are measured with the help of this 2 voltmeters present here. So once we know the values of VI and VR, then we can find the reflection coefficient K, which is nothing but reflected voltage divided by incident voltage, VR by VI. So after finding the value of K, then we can measure the voltage standing wave ratio by making use of the relation between VSWR and the reflection coefficient, which is nothing but 1 plus K by 1 minus K. So by this way, using a directional coupler, we can directly measure the values of voltage standing wave ratio. Thank you.